Hi guys, Justin Trabella here. Hope everyone had a good night and did well on your projects. I did a presentation on my phone which died roughly around 11:50. So I got the demo of the presentation done. So I'm just gonna talk for as long as the presentation going until my phone turns back on. But I did my project on Swift UI, Swift programming language. So a little brief intro here. So at the beginning, we all had a great feeling when we, started programming. We got the first ever Hello World to push out on the console. Starting to programming, in a language like Java was frustrating at first, but seeing all those unfamiliar words like static void main, now some million keystrokes later and many successfully failed successes I call them, over those really tough 30-liners of small bits of code. Display something, we wanted to get something to stand it out, and I managed to get that feeling again with Swift learning this past couple of months. So through many other languages like MIPS, Racket, Assembly, RISC-V, Python, C. Many of the languages has its design flaws, but dependability and reliability are close with Swift. Swift's IDE, Xcode, which is seen here in the video, is only currently reliable for just its own lineup of products, as it does not have support for Windows just yet. That's coming soon. Xcode is still early in its days of testing, as Swift is relatively new, as it was launched 2015, mainstreamed 2019. It's really picked up its slack. It's not as advanced as some of the other programming languages out there, but you see how intuitive it is on screen. Swift's IDE, it's efficient, but it crashes efficiently, and it gets back going up. You'll see I enter some things in different locations, and the GUI updates relatively fast. That's what's great about this dynamic programming style. UI is its core feature. 22,000 App Store downloads, or App Store games, applications pushed out just alone in 2021. So overview of the learning expectations. Intention is to give you a brief introduction to the programming language. As you watch the demo, programming has become a widely taught subject, and Xcode's relatively new, with programs like GitHub's Copilot and ChatGPT on the rise. Learning to program dynamically will be relatively easy. Jobs are going to start popping up. So I did an HC human-computer interaction class. We were doing prototypes. My project was around 3,000 to 5,000 lines of code with close to 8 to 10 different files working simultaneously. And I did it relatively quick. It's very easy to work with. The language is very easy to learn. So I really enjoyed systems programming, learning C. Most of the languages, Swift in particular is a descendant of Objective-C, so it's within the same branch. They just made sense to me. The purpose for this project is to demonstrate learning components of programming language at its core, its effects and influences it has on the experience of the language to benefit its developers, and I'll also detail where it stands out in the field of computer science. So originally derived the programming ecosystem language of Objective-C, shortly released after 2015. Many different operating systems, Mac OS, iOS, iPad OS, Watch OS, all running independently on their own type of software until UIKit and Swift was being developed. Now they're all integrated into one because it's that simple. It has also become a beacon for server-side development, machine learning, and web development. Being an open source language is one of the largest and active communities of developers who contribute to its development. It's become a significant programming language in the field of computer science, and it's a very efficient tool for building on the Apple ecosystem. So I chose Swift because I really enjoy it. It's a very simple and elegant language. It's near as close to English and as nice looking as Python did. Java, we all had our ins and outs with that. So it was designed to be an easy to read, write language, the emphasis on clarity and simplicity. Steve Jobs, creator, believed the programming languages used to design the system should be easy to read, write. It should allow developers to focus more on the tasks at hand rather than the syntax of the language. His attention to detail and emphasis on accessibility, inclusion, innovation, forward thinking is relatively reflected greatly in the Swift programming language. And Swift has greatly flourished because of his principles. And Swift combines powerful security and usability, flexibility in programming styles, overall adaptability to learn a new language. So it's relatively simple. So as you can see, the syntax relatively straightforward. My variables, let, my constant. It all comes right off the tongue. The lack of semicolons, which is great. It's one of the nice implementations. The one program we knew it was running right, but it was just a semicolon. Killed us for a very long time. So it's currently working, writing code and designing UI, UX elements. Very simple. I'm dropping the text right in, and it's updating very fast. It's a site-safe type language. Lexical structure of Swift syntax and grammar is close to other languages. Designed uniquely and syntactically like other language. It's very simple to read. It's built using LLVM, low-level virtual machine compiler framework, which means that it can go from assembly language machine code extremely efficiently, ultimately optimizing the Swift code. Makes it easier to develop faster, it saves time, and a hell of a lot less code. Along with Apple's POP protocols, it's protocol-oriented programming, just like we have Java with object-oriented. It uses its resources very fast. Most of the data is taking up most of the internal operating power. So it's really neat. Compiler makes it easy and friendly for methods for searching, accessing, redeclaring, using functionality of libraries, dependencies, APIs. That's all loaded on call very quickly and discards it relatively fast. So the current potential of Swift applications and limitations. The language, as of recently, there's a lot of current potential applications for programming language and it's basically limitless. Some of my limitations, I see that since I've been predominantly backward compatible, there's very limited support for non-Apple. Objective-C related devices, software platforms, limited backward compatibility is one of the biggest issues. Some of the possibilities I see: continued growth of the mobile and tablet OS app development industry. Recently, integration is on agenda with Windows and Microsoft. So the syntax provides a lot of great features in terms of the types of data that it can handle without compromising the memory of the system resources. Due to Apple's memory management system. I had a name for it here, misplaced it. It has an almost instantaneous feedback loop system showing live errors, messages quickly. and it allows its resources to anticipate errors and update the view simultaneously, so that as you're working, before you're running the full application, you can test and see those errors in real time, which makes it very dynamic way to test and program things. Library works in parallel with this, allows it to share and update libraries instantaneously. Along with a strong resource management system, Swift is developed as cross-platform. It can run, like I said before, multiple applications with relatively maybe two dozen lines of code, which allows the screen size to change and the operating system to handle its changes, but all the code's optimized to work efficiently the same way. So that's what Swift has done. Potential in the industry is limitless. It's easy to scale a product. An example of Project Lift redesign, the original code base they had was 75,000 lines. So it's easier to scale the product and the team. The app was recreated, same functionality, with less than a third the amount of code. And originally, it was done within a week, compared to, I don't know what it was before, but it only had one engineer. So object-oriented follows this hierarchy where everything has to get inherited from the parent class. Apple uses the protocol-based one, so that uses a protocol, and you, depending on what it is, you can assign different protocols, and as long as it adheres to a protocol, it could pass that on to another variable and lose it, in a sense, whenever it needs to be updated and doesn't need it anymore. Takes on more, and you can still access those old variables, the old protocols, since they were already declared. So here we have a string from an entity, and it takes in a name and a UUID. The extension allows the name to be overwritten, and it's just the UUID. And then the entity becomes a protocol of a struct called order, which takes on the name and the UUID from the order. But the struct only uses order, and it still has access to the entity's UUID function. So it never really inherits it, but it can process that protocol, which makes POP very efficient. Good for object-oriented, as it's stern. The inheritance in the abstract gives it a little bit more adaptability, or lack of adaptability, and efficiency. Also benefit applications by testing, by being able to create mock objects and test in other places. So unique features. Swift provides a lot of great features in terms of types of data, and can handle without compromising memory. Swift's compiler, its IDE Xcode, great benefits from allowing to designate its resources towards type checking and error handling pre-compile time. So the way Swift utilizes its dynamic library system in parallel allows it to be shared amongst libraries. Since all of its integration was open sourced, interoperability was a huge influence in the updates. Some of the benefits that we see from this exists in frameworks like Cocoa, AppKit, UIKit. Recent times, Swift has become much more mature. Apple started transitioning its older Objective-C based frameworks over to Swift-esque-like framework. And in recent times, Swift becomes more mature. Apple started transitioning its older things relatively recent. Some of the drawbacks, although I must say there's still a lot of work to be done on the compiler. Other than that, it crashes relatively often, but it's still consistent. Interoperability was one of the downsides. The language still is, an infant in terms of how new it is. Version control is not that great, as it needs a lot of maintenance from all its updates. Many updates to new languages relatively fast. A lot of people are intimidated by how hard it is, but once you get the hang of it, it's relatively fast. I got my software engineering project I'm doing right now. I have close to 16 files, working on about 300-400 lines of code each, and it populates the UIs fast. Only calls them when they absolutely need to be. Some other things that's become more mature. Apple started transitioning the syntax, highlighting, auto-completing compiler. So the UI framework works with Swift and uses its powerful inferencing type systems. So you don't have to declare all your variables. The compiler knows what kind of data and can manipulate based off those protocols. It has a great set of data type systems that it can use. Ones are optionals, which can take in data if there is data present, which the security side of things, guarding and if letting, makes a great way to block out whether or not those variables don't actually get data put them. And the optionals, you can force wrap or unwrap them to also prevent against data leak. So another one would be the computed properties, which works just like a function, but rather than calling the function, it locates the memory to the variable, and you open up a closure, and within that closure you can run a few items of code, and it updates the UI very fast. So as you see here, it uses a at state property, which updates the view anytime there's a change to that one variable. Same thing with the closures, anything within the closures and gets changed. Anything that's listed as a variable without an at state, those are stagnant and don't get updated as frequently. Most of where your variables sit are underneath this Swift UI view above the body, and all your UI elements go in here. It runs on a model view model framework, or that's their system that they use. So that's what makes this updating relatively fast. You use all your view models in different files and allow the compiler to use its memory management system to update the views relatively quick, like it does with the libraries, only when it needs it. So here this struct shows the preview provider here, and you're able to run on any types of different devices. This was Swift and Xcode, and thank you for listening.